So everybody, welcome to dissecting request direct move. What we're going to be doing here is actually reaching into the engine code, looking at the request direct move method, and then getting logs of these AI tanks and laying them out on the terrain so that we can see where our AI tanks are trying to go. It's the stage before we actually make these AI tanks move. So this is going to be fun. Let's go and get it done. Hey guys, so with reference to the diagram we built in the last video, we have the nav mesh in place. We want to go into our tank AI controller as a starting point, and we're going to follow the arrows left to right. And we're going to go and use this move to actor method that will already be right there for us because we're inheriting from AI controller. So into the tank AI controller then, into the CPP file, we already have to do that says move towards player. I'm going to get rid of the word to do under the tick method. And I am going to go ahead and say move to actor, and I'm going to look at the signature of what comes up when it comes up. Good old Visual Studio is still busy searching through the 3, 4, 5, not sure how many million lines of code that is in the engine. So that is the dark side of having a large engine like this. But anyway, in a moment this will come up. Here we go. It wants a pointer to an actor. Well, we have one. It's called the player tank. And it also wants a whole bunch of other stuff, including an acceptance radius. Now I'm going to assume that's in centimeters, and that it is the distance that when the AI tank gets that close to you, it stops. Now, we want that. We want about 100 meters away. We want the tank to, maybe a little less, maybe 30 meters away. We want the enemy tank to stop and start firing at us, right? Or at least just stop moving towards us rather than crowding us. So I'm going to make a default acceptance radius of 30 meters, which is 3,000 centimeters. But I don't know for sure that's in centimeters. In fact, let's check the documentation. I don't think it's going to be very helpful. Move to actor unreal. We could use this one here. It tells us about the blueprint, but it doesn't tell you what the units of this acceptance radius are. So that's not particularly helpful. So I'm going to do the following. I'm going to say to do, check radius is in centimeters. I'm then going to, instead of actually just putting a value in here, I'm going to make a parameter which I can move in blueprint. Acceptance radius. I'm not going to worry about the rest of these parameters. This stop on overlap, well, its defaults to true. We would want it to stop if we were to overlap with the AI tank. We want it to use pathfinding. This would all be a massive waste of time if we weren't. We probably don't want the tank to be able to strafe, but it doesn't really make any difference because we're going to be forcing it to use our physics, and later on we're going to get rid of the ability to move sideways anyway. Tanks don't move sideways. Remember, you can't strafe a tank, fool. And the rest of it we're just going to ignore. It's all got default parameters. Let's just go with the acceptance radius. So on the tank AI controller header file, of course, we need to make ourselves a private float called acceptance radius, and I'm going to give it a default value of 3,000, which I'm going to assume is in centimeters. And why not say what it is? How close can the AI tank get to the player? Well, that's it. Just keep it simple. How close can the AI tank get? Fantastic. So let's put the header file on the left just for OCD purposes and compile up. Now, we're not going to see anything change here because all we've done so far is just make this call into the pathfinding logic. We're not going to know that that's working until we start intercepting the call into request direct move, which I'm going to give you the satisfaction of doing. But I just want to check that the game still runs. We haven't done anything daft. And then we can turn our attention to the right-hand side. So inside the tank movement component, .cpp file, we are going to need to create a method which is in here somewhere. It's going to be the request direct move, and of course we'll have to declare it in the header file. We'll make it public to start with, but before we even start, I'm going to say check best protection of this method because we don't know for sure it has to be public, but let's start with public to get it working. And what I want you to do is go find out what the signature of this request direct move file is. Whether you're in Visual Studio or Xcode, you can go to the engine, UE4, source, runtime, engine, classes, and I'll give you this path in your challenge slide, game framework, and eventually you will get to the nav movement component, which remember is what we are inheriting from. This is the code that we are actually inheriting from. Good old open source engine. And in that nav movement component somewhere in this, you will find the request direct move that you need. So you're diving into the engine code. Get the request direct move signature. Find the nav movement component.header file. Copy the signature of request direct move, override it in your tank movement component.h, just like we override begin play, but there's no need to call super this time because we're completely replacing the functionality as to what we do when we move. We're manually doing that. Log the tank name and the value of the move velocity, and that is your path you're looking for to go and find that file. So go ahead, pause the video, see if you can make this work now and actually get some vector log values out that make sense from tanks that are in AI tanks that are inside the nav mesh volume. Okay guys, welcome back. This is exciting. I'm looking forward to this. So I'm going to do a find request direct. I'm going to look in just the current document and I can't find it. So what have I done? I've missed an E. Request direct move. There it is. Virtual void request direct move. It's nearly exactly what we need. Let's go to the tank movement component header file. Under here, I'm going to put it in the public section to start with. I've already got a to-do to check that later. Virtual void, I'm going to put the word override on the end, which makes the compiler check this is exactly the right signature. That's cool. So I've got that. Let's go into the CPP. We need the class name in here. And of course, when you do these overrides like we've done before, we drop the word virtual. Okay, so there we go. Now we don't need to call super. Let's put a reason why. No need to call super, as we're replacing the functionality here. I don't care what the functionality of this method is. In the parent classes, I just care that the pathfinding logic is calling this method with a very useful piece of information, which is what velocity do I need the tank to move in this frame. That's the bit of gold I want to capture from this. So let's go capture it. Let's have a few things. I said we wanted the tank name. So the tank name, we're on a component here, so we need to get owner. Then we go through the owner to the name. It's already going to be a string, so that's done. We're also going to have the, we want the move velocity string. So that is just going to be the move velocity. .toString. And that's good. So now let's do our UE log. Really ought to set up a keyboard shortcut for this. I type it often enough. UE log, log temp, warning. So it's yellow, text. So, well, it works. And then we're going to say the name of the tank, which is %s. Vectoring 2, and then another string, and then we just say the tank name, tank name, and the move velocity string, remembering to put your stars in front because we need to do that with strings in UE logs. We should know that by now. And finally, I think we have the call that we need. Let's go ahead and see if it'll compile. I'll leave the code on the screen for you. That is the implementation code. The header file code was simply that. Now, about this let's just get on with it now that it's compiled so quickly. So, look at this. Tank BP569 vectoring. Let's just stop the game for a minute and have a little look. So it's only 569 that's vectoring, and it's vectoring in a minus. Now, it is not a normalized vector, but, and you can ignore the Z because its value compared to the X and Y is tiny. So it's moving in like 700,000 X and minus 700,000 X, 800,000 let's call it, minus 400,000 Y. So in the compass terms, if X forward is north, it's moving in a sort of south-southwest direction. So let's look from above and see if this is feasible. Here's positive X, so north is to the right confusingly. The player start is there, so yeah, that is a south-southwest direction if this red arrow is north. So that looks very feasible. Let's bring the other tank onto the play space, and let's put it, say, directly, what I would call south of us. This thing should vector pretty much directly along the X-axis. Let's try it. Now, of course, you can't see it because the log is obfuscated. There's a good word. Now, you've got two tanks. Let's take that the other one is the correct one. Yep, 183 is vectoring. Look, perfect. 66,000 in the X direction and negligible in the others. Now, it's got a pretty big Z, actually, on these. 14,000 is not completely negligible. So it is trying to have a bit of a change in up-down, but we'll see whether that's a problem or whether it's working. It might just be because my tank's still up in the air at this point when I'm logging, and that once it settles down, like now, that the Z, yeah, has dropped a bit, but not completely. But it does have a three-dimensional direction, but that's okay. We're just going to look at the X and Y. But look, the triumph here is that if the AI tanks are in this nav mesh and we are in the nav mesh, that we're actually getting a vector from them as to the direction they should start moving. Now, there's one final thing we should check here for fun. We should take this tank and this other AI tank and put it round the back of this place like this, say here, And then let's put the player start the other side. And let's actually just ditch the other tank out of the nav mesh area, just for simplicity. Okay, so this means that this tank, BP2, or better known as _183, is trying to get to the player start point, which is over here. Now that is, let's make it actually due north of us, or due in the X direction of us, something like that. But the vector should not be that direction. It should be up here. It should be northwest, if you like, which should be positive X and a similar amount of negative Y. Let's see if that's the case. Positive X by 75, negative Y by less than 75. That means it's going quite directly towards this hill, and then it'll probably hug the hill. That's absolutely fine, but it looks about right. The key is it's not heading directly towards us. If I move it closer to this hill and further down here, this guy should now start trying to vector in a fairly positive negative Y direction up here to get around the hill. Let's see. What's he doing? He's going X with 20,000. You know what he's doing? I think he's trying to go around the other side of the hill. So what I'm going to do to just check this is I'm going to get the nav mesh bounds volume, move it over the hill so it fully encompasses the hill, even if we need to make it bigger. Yeah, I'm just going to scale up my nav mesh bounds volume to 200 by 200. This is all good learning as to how this works. So it takes a little while to compute. There it is, perfect. Now, let's say the AI tank is there and the player start position is here. Let's see what type of vectoring the AI tank tries to do now. Okay, let's look at this critically. It's 100 in the negative X, so it's going back this way. But more significantly, it's 350,000 in the positive Y. So it's kind of going this way, probably because it's near the base of a hill and it doesn't want to go up that hill anymore. So we could put it somewhere else, like in this little alcove here. You can see from the camera roughly where it is. Let's see where it tries to vector now. Okay, and then let's look at that value. It's going minus 100 in the X, so it's going backwards a little bit, and 350,000 positive in the Y. So it's probably just backing off that hill. So we're not going to really know if this is doing the job properly until we have actually start making the move, which is going to be the subject of the next video.